Bohr Atomic Model, Conductor and Insulator. The image explains the Bohr Atomic Model and shows how the arrangement of valence electrons determines whether a material behaves as a conductor or an insulator. At the center of every atom is the nucleus, which contains protons, positive charge, and neutrons, no charge. Around the nucleus, electrons move in fixed circular paths called electron shells or energy levels. N is equal to 1, N is equal to 2, N is equal to 3, etc. According to the Bohr model, electrons can only exist in these fixed energy levels and cannot stay between them. The image also highlights three important principles of the Bohr model. Discrete electron orbits. Electrons move only in fixed shells around the nucleus. Energy quantization. Each shell has a specific energy, and electrons can occupy only these allowed energy levels. Photon emission and absorption. When an electron moves to a higher shell, it absorbs energy. When it returns to a lower shell, it releases energy as light, a photon. Conductor, example, copper wire. On the left side of the image, a copper wire represents a conductor. The valence electron, the electron in the outermost shell, is shown as free. This means it is only weakly attracted to the nucleus and can move easily from one atom to another. When a voltage is applied across the conductor, these free electrons begin moving in the same direction. This movement of electrons forms an electric current. Since many electrons are free to move, conductors allow electricity to flow easily and therefore have low electrical resistance. Example: copper, Cu, silver, Ag, gold, Au, and aluminum, Al, are good conductors because they have one or a few loosely bound valence electrons that can move freely. Insulator, example, plastic or glass. On the right side of the image, the atom represents an insulator. Here, the valence electrons are tightly bound to the nucleus. These electrons do not move freely because a large amount of energy is required to remove them from their shells. When voltage is applied, almost no electrons can move, so electric current cannot flow through the material. As a result, insulators have very high electrical resistance. Example: plastic, rubber, glass, ceramic, dry wood and air are common insulators because their outer electrons are tightly held by the nucleus. Real-life example. Consider a household electrical wire. The inner metal core is made of copper, which acts as a conductor. Its free electrons carry electrical current from the power source to an appliance, such as a fan or light bulb. The outer covering is made of plastic or rubber, which acts as an insulator. The tightly bound electrons in the plastic prevent current from flowing through the outer surface, protecting people from electric shock. Summary. The Bohr Atomic Model explains that electrons occupy fixed energy shells around the nucleus. The behavior of the outermost, valence, electrons determines whether a material is a conductor or an insulator. In conductors, valence electrons are loosely held and move freely, allowing electricity to flow with low resistance. In insulators, valence electrons are tightly bound to the nucleus, preventing electron movement and resulting in high resistance. This simple atomic concept explains why metals like copper are used for electrical wiring, while materials such as plastic and rubber are used to safely cover those wires.